Hello friends and welcome to a lecture on operation research. Today we will be looking into a queuing problem. The queuing problem is of the type M/M/1 infinity/FCFS. This is Professor Arvind Prasad. So let's have a look at the problem. A television repairman finds that the time spent on his jobs has an exponential distribution with a mean of 30 minutes. If he repairs the sets in the order in which they came in, and if the arrival of the sets follows a Poisson distribution with an average, that is an approximate average rate of 10 per day, that is 10 sets per day, what is the repairman's expected idle time each day? That is, what is going to be the slack, or is he going to remain idle in the day where he's not going to have any set to repair? That's what we need to find out. And the second thing that we need to find out is how many jobs are ahead of him of an average set just bought in. So at any instant, okay, if he has received a set, how many sets does he have to really repair? One of the sets is the set which he is going to repair, which has come to him, and he immediately needs to attend it. Now, how many sets are behind it? So we need to know the total in an hour's period. So let's go ahead and solve it. The problem is of the type M/M/1 infinity/FCFS. Now, what does this mean? This means that the arrival rate has a Markovian distribution. The service time also has a Markovian distribution, and the number of servers is 1. In this case, we have only one repairman, and the system has infinite capacity. That is, any number of sets can come in, and that's reasonable to assume because the number of sets arriving does not depend on the number of sets in the system. So they're just independent of that. And FCFS means the service discipline, that is first come first serve. So the set that comes in first gets service first. Now in an 8 hours, 10 sets are bought in. So the arrival rate of set is 10 sets in 8 hours. And the repair rate is 16 set in 8 hours because he takes 30 minutes to repair a set. Now what is going to be the free time in an 8-hour shift? That's going to be 10 sets divided by lambda. That is the time required for 10 sets to come in. So we know that 10 sets coming in 8 hours minus 10 over mu. So 10 over mu is going to be the time that he will spend in repairing 10 sets. Now the difference of this time is going to be nothing but 1 minus lambda minus 1 upon mu into 10 if we remain 10 as a common factor, and this is going to be 3 hours. Now at any moment, what is the number of sets in the system in any hour, we can say? So that's going to be ls is equal to lambda mu minus lambda. That's going to be 2 sets. So in any hour, at any instant, it just starts now. Now we take a period of 1 hour, okay, an average period of 1 hour. So in that average period of 1 hour, at any instant, a starting instant and going ahead 1 hour, there are going to be 2 sets with him. That is one set which has immediately arrived at that instant, and an average, not an average, but a time difference of 1 hour. So there would be one more set lined up. So ls is nothing but the expected number of sets in the system at any instant. So that was all, and this is the solution of the problem. If you like my video, do subscribe it, and do also press the bell icon and share it with your friends who would benefit from learning from it. Goodbye. Have a great day.